bypass the water softener, which I'm going to say yes this time. We're actually changing that, so you don't have to do that. So now we bypass that because when the machine's been off for a while, they come with a water softener. This is the water softener right here. So they actually come with that, which is a really important part of the process for us to have the water be soft. And then there's also a 5-micron filter, which looks like this right here. That comes with the machine. So these are the parts that you have to change. This and the resin in here basically are the two. Those are the two consumables that none of the other ones have, okay? This is, I think, one of the most important features, and it took me a long, long, long time to figure this out and get this done. Okay, so what happens here is when you put salt in there, that salt is going to dilute up to a certain point. And then after a certain point, the salinity of that water just stops. It's not going to fully saturate. I mean, it's going to stop at some point. It's going to only saturate to a certain point. However, okay, so that's what happens. So, but when I have this machine running, what happens if somebody comes in here? Where'd that come from? What happens if somebody comes in here and while this machine's running and says, "Oh, the water's a little bit low in that tank. I'm going to put more water in here." Okay, let's say 50% more. So it's going to dilute the saturation in half. Well, when it dilutes it in half, if I don't make an adjustment up here, then this peristaltic pump is going to be moving at a certain speed, and if I don't adjust that, then I'm going to have half as much brine coming in, and that's not going to produce the product that I want, okay? So, what happens right now, and we added onto this is the electronic cabinet, we added into this side is this pump motor control card over here. This pump, this thing right here, and this right here, and that right there, those are all motor control. So what this does is a pulse width modulation that controls this pump. So here's what happens. The brine solution, as it's coming in through the water into the cell, the way that we can measure the amount that's going in there is by looking at the amperage. And that'll show up here, because as the conductivity of the water changes, the amperage goes up. So if I had no salt in there, we turn this on, we send 12 volts, which is constant voltage, then 12 volt direct DC to that. Voltage doesn't change, but as we change the conductivity of the fluid, the amps change, okay? So what happens, I turn this on, my amps are where we want them to be set at. Let's say it's 12 amps is what I want this machine to be running at. And all of a sudden, somebody pours water in that thing, and I don't change the speed of this pump, I'm gonna have half as much solution in here, half as much saturation in here. All of a sudden my amps are gonna go down to 5. Well, that's not good. So what happens then is the microcontroller reads that amperage across a shunt that's in here. It's reading that amperage, and it goes, oops, amperage is 5, I need to speed this up. And it'll do it. And then after 3 seconds, it takes one reading every millisecond. Right. And after 3 seconds, 3,000 milliseconds, it averages all that together. And once it averages those together, it says, do I need to turn this up or down? Do I need to speed it up, down? And it does that on these two valves as well. These are pulse width modulated also. These control the catholyte, and that controls the water.
So I would assume the saturation and dilution varies all the time based upon the level of water in this tank. And so it's a constant mover that this is constantly adjusting to. Would that be inaccurate?
Not really. I mean, basically what happens is, once, like if I fill this all the way up to like here with water, and after about 24 hours, it's going to be fully sat. This will be fully saturated. And so even as this continues to drain down, that saturation is going to stay the same. It's not going to, more salt's not going to dissolve. You'll have the same, because it can't. It's already fully saturated for that entire, because it's homogeneous at that point. And so as that drains out, but as I add more water, then it's going to change that saturation. And then we have
But
need
you
for
got to constantly add water, right?
Yeah, well, it takes a long time in that one. Yeah, I mean, it could be days.
I don't know how fast it draws
days.
that.
It would
days,
that one there would take about a week or something to.
Really?
Here.
Okay.
Yeah,
that's helpful.
Because you're only putting 7 grams per liter of salt in here. So as this peristaltic pump is turning, it's just barely. It's just dripping into the water line that's shooting water through here. That's coming in from out here through this, water softener. So it's a small amount. It's a really small amount that's coming in there, and the machine has. They're not hooked up here, but sensors that'll go in here. It's a level sensor. So the way our level sensors are made in real life, the way this would work, is the level sensors hang in the top of the tank. The tank's usually full up to here, and I only have a variance of about this much. So that level sensor can move just a little bit. So every time that level sensor, when it drops down and hits the bottom, it says, I need to refill this with brine. It tops it off. because I don't ever want that problem
Okay.
of like really
That makes
getting
sense.
all the way down there and then throwing it
right.
back. I just want to keep
That's
topping
what
it
I was
off.
thinking.
Just
Okay.
topping it off, topping it off, topping it off. So that's how that would, you know, the machines that we put out there, they have the level sensors in them. Same thing for the Danolyte tanks and others. There's level sensors that my amperage drops down, way down. I'm out of spec because the machine knows I'm supposed to be at 12 amps. This valve clicks the other way, and the fluid that would have been going into the Danolyte tank now goes to the waste. And it'll stay in the waste until this thing speeds up enough, it gets right, it says, okay, I'm back to 12 amps, boom, now I'm back, good product again. Same thing happens if the water flow gets out of whack, if the pH gets out of whack. Water flow can get out of whack. We say 20 liters per hour, there's a flow meter that you can't really tell, but it's that thing right there is a flow meter, it's hooked to this. So when the flow meter says it gets to 20 liters per hour, perfect. But if somebody flushes that toilet and turns that sink on at the same time, that's gonna drop down. And we can set a tolerance on all of these. So I can say, okay, if that moves, you know, 0.1, then divert, go into the waste. Or if I'm okay with 0.1, 0.2, 0.3, something like that, I can set those tolerances. Same thing with the pH. If the pH changes for some reason, could be a lot of reasons why that could happen. pH gets out of whack from where we're set, then this will divert and send it to waste, basically. So pretty simple inside of here, though. What we try to do is, and I know it looks a little messy right now just because it's not tidied up, and we'll look at another one, but is to kind of keep things nice and tidy and clean, reduce the number of connection points, and we actually reduce the number of valves. And then also, each one of these valves is optimized in terms of its energy consumption, because I foresee this at some point being something that could be solar. Absolutely. So, for instance, this valve, very unique.
We hope you found this interesting. To learn more about Danolyte's just-in-time generating systems, give us a call at 913-489-7600. We look forward to talking to you and learning more about how we can help. Thanks.